Hello, I'm Mr. Bob, and welcome to my Geometry Review video series. This video covers Chapter 11, Section 6, titled Locus, a set of points. By the end of this video, you will have reviewed recent lessons describing a locus, a set of points. You will draw and describe a locus on a plane and in free space. Additionally, included, you will be reviewing a locus defined by two conditions. If you'd like me to cover any of these topics in greater detail, please leave a request in the comment section below. Please subscribe to this channel if you find this video to be helpful. Thank you. Okay, let's start this review with a definition. It says a locus. A locus is a set of points, all of which meet a stated condition. To sketch a locus, draw points of the locus until you see a pattern. We're going to see that done here as we move forward. Okay, this is objective one, so you'll see that the definition we just looked at is exactly the same as what's written here, but it says a locus is a set of points, all of which meet a stated condition. To sketch a locus, draw the points of the locus until you see a pattern. So you're going to be putting points down at a certain distance or whatever from a spot or a line or whatever the case might be, and you're going to put these points in, and eventually you're going to draw enough points and you're going to say, oh, I see what I'm drawing. I'm drawing a circle, or I'm drawing whatever, parallel lines or something. You'll see how that's going to work. But that's what it's just drawing a set of points, and those points will all of a sudden, you'll see the shape be presented before you. Okay, in example one, we're going to be looking at a locus in a plane. So it says for A, problem A, or statement A, if you will, draw and describe the locus in a plane, the points 1 centimeter from a given point C. So what they're saying is, here's your given point. We've drawn right here in this little picture. It's right here. Here's the point. Right. I'm gonna change the color before I even go on there. Let me change that to red. So the point here's the point that they're giving us, and they're saying draw just random, not randomly, but around in the circle, points 1 centimeter from that point. So as you're going to go around, you're just going to kind of go ahead and start tapping 1 centimeter all the way around, and eventually, as you do that tapping, you're going to start seeing something's going to kind of present itself, right? What are you going to what are you seeing? If you do enough points, eventually you're going to see a circle appear. Okay, so that's kind of what we're seeing here is this circle. So this is what they mean by draw points from a point. Okay, it says over here on the right hand side, it says draw point C, sketch several points 1 centimeter from C, which we just did, and draw the figure and until you see a pattern. It says draw the figure the pattern suggests. Well, I guess that would be very much would be that we drew this circle here. Over here, I've drawn a lot more points, but as you see this is the infinite, this circle, which isn't very good, by the way. But that circle is the infinite number of points around point C that you can draw. And if you draw enough points, you'll see a solid line, so to speak. For point B here, or for section B of this slide, it says draw and describe the locus. In a plane, the points 1 centimeter from a segment AB. So now we're talking about a line segment. And the locus is two segments parallel to A and B, and two semicircles centered at A and B. And you'll see it. If you start doing your lines, everything's 1 centimeter from this line, this segment AB right here, this segment. You're going to draw these dots 1 centimeter. And when you get to the edge, look at that. You're still 1 centimeter from now point A. You're not going any farther from point A as you go around, 1 centimeter. And now you're kind of 1 centimeter from the lines as you're going around. And you're going to get to this point. Oh, look at that. So to stay 1 centimeter from B, which is the farthest we can get, we're going to go around and could create another semicircle. And now you see what it did. It drew two segments parallel. Here's the parallel segments. This segment's parallel to, and this segment is parallel to AB, and two semicircles, which is these. You draw a semicircle out here and a semicircle over on this side. Okay? So hopefully you get the kind of the gist of what they're talking about. Okay, example one, check your understanding. They would like you to try this one. The directions say draw and describe the locus in a plane, the points 2 centimeters from a line XY. It says you can use a locus description for geometric terms. Well, what are they asking for? They're asking you to draw this line XY and then give us the 2 points. So why don't you try it on your own? The pictures on the bottom are for, we'll talk about that after we do this little experiment here. So go ahead and pause the video, try, draw your lines and see what you come up with. Then we'll try to do the same thing and we'll talk about it. Okay, now that you've had time to look at that, so let's see. It says draw and describe the locus in a plane 2 points, 2 centimeters from a line X and Y. So what I'm going to do the first thing, as you know, my drawing is not all that great when I do it, but I'm just going to try to draw a line. Not bad. And I'm going to put a line, arrow on each end. Okay, I got arrows and I've got a point here and a point here. Okay, and I'm going to call this one X and this one Y. So we have a line and points X and Y, and it says draw in a plane, draw the line 2 centimeters, points 2 centimeters from the line. Okay, so you can use the locus description. But what we're going to do is I'm going to pretend like 2 centimeters is up right about here and about right here. Okay, so I'm going to go to red. So what they want you to do is continuously draw dots that are 2 centimeters from this line. Well, guess what? I'm sorry, it dropped down. It looks like I can't do parallel very well. But the point is that these dots remain 2 centimeters at all times. So it's not going to go around the corner like the other one because the other one was a line segment. Here, you can't get any closer to the line. The dots have to go continuously, right? So, and they're parallel. So what you've done is you've drawn two parallel lines. Okay, 1 second. Let me get the other one. Sorry about that, but I've been having this throat thing going on where I've been getting this tickling thing causing me to cough. I'm sorry, I had to stop the video there. Okay, so now let's move on to these two pictures. And what they're showing here is an angle bisector. The points in the interior of the angle that are equidistant from the sides of the angle. And the other one says a perpendicular bisector of a segment in a plane, the points that are equidistant from the segment endpoints. So what there you see the black line and the blue line. Well, what they're showing you here is that this angle bisector is saying, give me the set of points. This is the set of points here that are equidistant from the two lines as you go out. And if you did that and go forever, you're going to have the angle bisector because each one of these points is equidistant from the line that you're, right? So it puts it right in the center. The same thing with the perpendicular bisector. It's saying in a plane, the points that are equidistant from the segment endpoints. So I can draw the point here, which is equidistant from point A and B. I can draw a point here, equidistant from A and B. Equidistant, and equidistant could be like this, right? It's the same distance. This line here, and when I put that point, it's the same point from here. If I slid this point over here, well, all of a sudden it would be short here and long here. It wouldn't be equidistant anymore. So the points all have to be, the line is created by a set of points that are equidistant from the endpoints. And that's what we're talking about here. It goes on forever. Okay? Good. Okay, in example 2, we're looking at a couple of two condition sets of points. So our points in our locus now is going to satisfy two different conditions, and we'll talk about them and we'll look at them here. So draw the locus in a plane, the points equidistant from two lines K and M, and 5 centimeters from the point where K and M intersect. Okay, so if we do that, we're going to look at, here's the first picture right here. It says the points in a plane equidistant from lines K and M are two lines that bisect the vertical angles formed by K and M. So if you, like we did in the last slide where we did the angle bisector, and we're going to get two angle bisectors, and we're okay by drawing lines. And so here we have lines K and M. Here's where they intersect. And if we're going to draw a bisector from these lines here, that bisector is going to go along this line here, right? This is your locus here, and it's going to go in this direction too. They're lines, they go forever. And then the other set, we also have a set that runs this way. So this is two conditions. It's equidistant from lines K and M and our two lines that bisect, okay? So these lines are bisecting both angles simultaneously, okay, or both vertical angles simultaneously. And the second picture says the points are 5 centimeters from the point where K and M intersect. Well, if this from here to here is five centimeters, we're looking from all the points from that center right there. So that's going to give us this circle. If you put enough points in, like they say, keep drawing points until you can see what you're looking at. And that's what we're talking about here. They intersect in a circle. Right here, that's what you've got. And then for the last one, this is two conditions that it's kind of makes the point really come home. So the locus that satisfies both conditions is the set of points A, B, C, and D. So you have the first condition is these lines here that are created by these points that we drew, right? So these lines go forever, right? They go up, over to the right, over to the left, forever. Okay. So then the other one was points 5 centimeters, and it gave us a complete circle because they just said 5 centimeters. So we have to do every point that's 5 centimeters from the center of that circle. Well, that satisfies that. Well, these are two different conditions. If you put these conditions together, you get this drawing down here, which is you get the lines that we were talking about, the intersecting lines, or that are the bisecting lines, and you get the circle. But they want that it satisfies both. And that set of points is it has to be equidistant on these lines, these bisector lines, and 5 centimeters. So the only time you can get those is where the line crosses the circle. Okay, so where the circle is struck by the line going through it, those 4 points is the combination of these two conditions. Okay? Okay, example 2, check your understanding. So here's one for you to do. It says, draw a locus in a plane, the points equidistant from 2 points, x and y. Okay? And 2 centimeters from the midpoint of the segment xy. So you're going to draw points that are equidistant from xy and 2 centimeters from the midpoint. So why don't you try it and see what you come up with? I'll wait. So now that you've given it a try, let's see what we come up with. So it says, draw a locus in a plane that points equidistant from 2 points x and y. So let's draw that first. So I'm just gonna, this is on a plane, right? So I'm gonna draw a point here, and I'm gonna draw a point here. Kind of doesn't matter. I'm gonna call this one x, and this one y. So then it says, we're drawing points equidistant from x and y. Hold on one second. Sorry, there's that cough again that I'm dealing with. From 2 points x and y and 2 centimeters from the midpoint. Well, where's the midpoint? Well, I'm going to say that the midpoint, I'm going to change to red. I'm going to say the midpoint's somewhere around here. I don't know, but somewhere like that. Be halfway between them. And it says the midpoint of xy. Well, there's a line segment we're talking about now. So we're getting a midpoint here. Here's the segment. Here's the midpoint. And what do they want, though? They want 2 centimeters from the midpoint and equidistant from the 2 points. So it has to be equidistant from the 2 point x and y and 2 centimeters from the midpoint. Well, the only way we can do that is if this is 2 centimeters and this is 2 centimeters. Okay, that's what we have here. Here are the points that are equidistant. They're equidistant from X and Y. I'll try to get some yellow on that. There it is. Equidistant. I wanted a different color. Oops. And 2 centimeters, which is this distance right here, the 2 centimeters. They're equidistant and 2 centimeters from the midpoint. Okay, that would look fun. Okay, example 3, describing a locus in space. It's a little more interesting to try to figure out how to draw this and present it. But it says draw and describe the locus in space, the points that are C units from a point D. Well, in this problem A or section A we're going to look at, um, they're telling you that the locus is a sphere with the center at point D and a radius C, right? So that's what you have to imagine that not only if it was a plane, of course you'd have all these radii coming out in every direction, all equidistant. But since it's a sphere, let's pretend like this D is a point on the surface of the sphere right here, right? I want to get that red. There. So let's assume that the center of D is actually sitting on the ball that we're looking at. Then you'd have this coming out there. That'd be the same thing out on the surface. Or you'd have one, if there was a point, if this was on the surface of the ball, you would have that would be also the same distance. So it makes a sphere. Every point around the ball, all having that same distance from point D. So it forms a sphere. And then here, B, draw and describe the locus in space, the points that are 3 centimeters from a line L. Well, if you go right here to the end, here's the line L, this dashed line is our line L. Okay. Well, 3 centimeters is up here. Well, if you go around this from the end, you can kind of see it. It's created a cylinder. So all the dots going around are a cylinder, and that they can fill in all the way around. That's forever. All of these dots on the surface would create a 3 by 3, or it would be a 6 centimeter diameter cylinder of length, whatever the length of the line is, which would be infinite. But you see, the points are filling in around from the side, which is kind of interesting. Has a 3 centimeter radius from the center line. So that's how that looks. So this one, check your understanding. They'd like you to try it. Draw and describe each locus. The A is a plane, the points that are equidistant from 2 parallel lines. Okay. And B says in space, the points that are equidistant from 2 parallel planes. So now we're thinking of three-dimensional, a plane. Now these are 2 parallel planes, and they want points equidistant from 2 parallel planes. Okay. Why don't you go ahead and give it a try, and when you come back, we'll try to do it together here. Okay, I'm assuming you've done that. So let's do the first one. So it says in a plane, right? So I'm gonna see if I can draw it. We're just gonna draw a big square here and call that a plane. All right, as good as it's gonna get. Then on that plane, I'm gonna change color to red, I hope. And I'm gonna draw a line here, and I'm gonna draw another line here. Well, those are our 2 parallel lines. Don't laugh at them. Okay, so now you've got the 2 parallel lines, and they want you to draw points that are equidistant from the two. So somewhere it's going to be right here in the middle, equidistant, right? And since these are on an angle, I'm going to kind of draw that it's like kind of like a 90-degree angle here, 90-degree angle there, because I don't know the angle of the plane, but you get the picture where this line is through the center and is forming a parallel line, or a line that now we have 3 parallel lines, right? Okay, if it's equidistant, it has to be in the plane. It can't be above or below the plane. So these are 3 parallel lines now. The other one says in space, the points that are equidistant from 2 parallel planes. Well, I might have a real trouble trying to draw this, but let's see if I can. I'm going to draw a point here and a point here and a point here, and a point here. So that's going to give me this and this, hopefully. And I'm going to draw a point down here and a point down here. It's going to give me the front of this plane. Okay. And then if I bring this down to about here, and this down to about here, I can come across the back, and I can come down here, and come down here. Little wiggly lines, I'm sorry, guys and gals. Okay, so here we go. And one across here. The lines aren't part, these lines are not part of the planes. I'm just using that to draw what I'm going to draw next. So the dashed lines aren't part of the plane. Is this line here, and then this line here, not including that front line, and not that line. This line here is part of the plane. Well, that's about as good as it's going to get. Let's see if I can erase that one line. Let me see what I can do with that. This is a little bit, that doesn't need to be there, right? And that solid line there doesn't need to be there. That's a little closer to two parallel planes. So now let me go ahead now in blue. So now these lines here are going to help because now I'm going to draw a line parallel. So here, 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 somewhere out here. And I'm going to draw this line down here and here. You should be able to see that line here. You can't see that. And then you should be able to see this line coming out here. All right, so that's not great, but it's kind of what I'm, oh, this one crooked. Let me erase that. And I know you're all thinking, what the heck? These are the sloppiest lines. Okay, I can take that back to until it stops back. So you get the idea. The two outside planes, and then there's the one in the center. And it says, in space, the points that are equidistant from two parallel planes. Well, our parallel planes is this guy and this one over here. And the one in the center now is the one equidistant from both of those planes, right? So there's a line from the center here to the center there. That's equidistant from this center here to the center of that one. So they're equidistant, right? Center. That's the best I think I'm going to get it, but I think you get the idea. In space, the points that are equidistant from two parallel planes form another plane. It's the infinite number of dots. And these are all, I drew lines, but they're created by a bunch of dots, right? You're going to put dots everywhere in here that are equidistant, and you'll end up with a plane. All the dots will make the plane. It's not these lines don't make the plane. All the dots form the locus that you look at and you say, oh, that's a plane. That's kind of what we're doing here. We're trying to look at the dots and imagine or wait until there's enough dots on the surface until you can see, oh, this is forming a circle or a sphere or a cylinder or whatever it's forming. It says you can also think of a locus as a path. For example, the locus of the tip of the hand of a clock. Each day is the circle traced by that tip as it travels around the clock. So, because as it's going around, it's constantly creating little points from the tip. And when you're all done, it's going to have a path that it took, and you're going to see that path. It'll be all, so you got the clock. If you've got a clock here, right, with all your numbers on it, noon up here, 6 o'clock here, 3, 9, it's going to go around the clock, and it's going to make a circle all the way around. As that hand goes around the clock, it's going to make that circle. And that's going to form a path. It's going to have enough dots that you're going to see the path that followed. And then it says the locus of a point on a handle of a sliding door. So if you have a sliding door and you have a handle on it, and here's the floor, and if it starts, the handle starts here, and then when you open the door, it slides back to here. All day long, it's going to slide back and forth, and you're going to you're going to form that path right here in the bottom, which is this. This is the path of that door going back and forth, back and forth, back and forth. So if the points are equidistant from the handle at all times as the door slides open, you're going to get these points that are following that handle, that are equidistant from the handle in a single line on the floor. Okay, good. I think this is a good section.